The experiment that we're going to do is basic operation of an op-amp. So the first thing that we study in an op-amp is how to use it as an inverting and a non-inverting amplifier. The very first thing that we will do is try and use it as a non-inverting amplifier. So I go to components and I need to select an op-amp from here. I'm directly going to type the number. This is also an op-amp that you can use. The one that I'm using is LT1012. I click on OK and I get the op-amp. Before I start making the circuit for a non-inverting amplifier, I will add the power supplies or the voltage that you're going to add. So I add voltage, click OK, I get one voltage like this. Click on Ctrl R to rotate it and place it over here. So this will be your positive one and this one's going to be your negative voltage. Just so that I have the values directly, right click on V, put this as plus 15 volts. Again I right click on V and I'm going to put this as plus 15 because I've connected the negative terminal to my op-amp device. Once this much is done, my power supply has been given. The next thing that I will do is give it its negative feedback. So again press on Ctrl R. This is the first resistor that I need for negative feedback and I'm going to place my second resistor that I need for negative feedback. My entire circuit is not fitting in, so I've just made it a little smaller by pressing this symbol. Okay, that is zoom back. I will go ahead and make the connections now. I'll just place one ground here. I will also have to connect my voltage supplies to ground, so I'm giving one ground here and this ground I'm directly connecting it over here. Okay, for you to make your connections, click on the wire and start making all your connections. Your resistor R1 needs to be connected to ground. This is going to take some time since I have to do a lot of connection. Resistor R2, I have connected it here. Resistor R2 will also have to go towards the output. So this R2 is basically my resistor RS, your feedback resistor. We'll change the name so that you should have no confusion. I'm connecting this to V plus and V minus connections are already done. So this should be what my circuit looks like. If I want to take output, I will need a resistor at the load end. I'm connecting this resistor will have to be connected to ground, so I connect the ground. Okay, I'll just name my resistors. Let me give resistor R1 the value of 1K. Resistor R2, okay. Instead of calling this R2, I right click and convert its name to RS so that things come in similar lines as to how you've studied them in theory. I have given RF a value of 10K. I'm converting this to RL. I cannot use subscripts over here, so that's how the value is going to look. Value of 1K. Now I need to give my input. So again a voltage source, click on OK. This is going to be my input, so I'm going to place it over here and make my connections. It's a non-inverting amplifier, so it will get connected to the positive terminal. Okay, I will also have to connect this to ground, so I'm giving a ground connection over here and I click on escape. Right click on this voltage source and go to advanced. I want to give an input of a sine wave, so I select sine with a DC offset of 0, amplitude of 10 millivolts, frequency we'll use the standard of 10 Hz, time delay 0, theta 0, phi 0 and cycle 0. For most of our experiments till now we have kept this value as 0 and I click on OK. Now I come to this running man symbol, click on this. I'm going to use a stop time of say 300 milliseconds. Time to start saving and all I'm not going to keep, I'll just leave it as a default value and I click on 0 to get this over here. Okay, so now when I want to see the output, what output do you want to see? You want to see the output voltage, but first we'll check in what is the input voltage as well. So I come here, click on this which is my input voltage and you can see you've got a very beautiful sine wave that is going from plus 10 milli to minus 10 milli. I want to now see the output voltage. So I'm going to come here and click on this. This what you can see is your output voltage. If you remember the formula, V0 is equal to 1 plus RF upon R1 into V in. So RF is 10K, R1 is 1. So that will give you 10. 1 plus 10 is 11. So you can see this is slightly going above 100 millivolts. This is the amplified waveform that I am getting for a non-inverting amplifier. Now just take a moment and think, what will you do to convert this to an inverting amplifier? I'm coming back to my main circuit. I want to convert this to an inverting amplifier. What am I going to do? So I'm just going to close this output window and I come to my main circuit and I want to make changes here. First thing that I need to do is I need to remove this. Click on F5 and you get a scissor symbol. Remove this source. So my source is gone. I need to shift this ground. So again I'm going to click on F5. I'm going to remove this ground for simplicity purposes. I'm going to place a voltage source over here now, since my input is going to go to the inverting terminal. And you're going to put one ground here. You will also give a ground over here. The circuit is now complete. You again have to give a sine wave. So go to advanced, click on sine. You would not have to do this if you would directly copy paste the voltage source that we had before. But since it's the first time you're doing it, I'm going to show it to you this way. We have set everything. Click and you've got this. You don't want this to intersect with your circuit. Just press F7. Click on this. Get it done. Click on escape. You can see your entire circuit right now. Click on your running man symbol and you've got this over here. What if you want to see it on different panes? Just right click, add a plot pane. So I'm going to put my input first. This is your input, which is going from -10 to +10. Take a moment and think, what is your expected output? You know that it's going to get inverted because it's an inverting amplifier, and the gain is going to be RF upon R1. When we say the gain is minus RF upon R1, the negative sign is just the 180-degree phase shift. So select this, come back here and select the output that is over here. Can you see what has happened? This is going up over here, but your waveform is going down. You may not realize this is amplified because your sine waves look exactly the same, but then look at the x-axis. Look at the y-axis. This y-axis is going from -10 to +10. This is going from -100 to +100. If you don't want to see it on the same one, you can do one thing. Delete this pane, get a single pane, come back here, and now see your output. You can very well see it as inverted. You can also see it as amplified. So what we've done over here is we have taken the case of a non-inverting amplifier and an inverting amplifier. You normally use IC741. If you want to do that, you can download the SPICE directive and use it from there. But over here we are using LT1012. In the next experiment, we will be doing adder and subtractor using an op-amp.